The universe, by its nature, tends toward chaos. Yet, within this vast entropy, a highly improbable structure emerged: the sophisticated mind. Intelligence, in its rawest form, is the universe's greatest predictive tool, a counterforce to randomness. But what exactly is this capacity we call intelligence, and how did life master the blueprints for prediction? We habitually define intelligence by our own achievements: language, mathematics, abstract reasoning. But the evolutionary record demands a broader, more brutal metric: optimization. This is the story of optimization under pressure. Over 3 billion years, life underwent 5 critical cognitive upgrades that culminated in the modern self-aware mind. Analyzing these steps reveals not just where we came from, but where we are inevitably heading. Our journey begins long before neurons, when sensing the environment was merely a chemical reaction. The first great leap of cognition wasn't thought, it was responsiveness. To survive, life needed to differentiate signal from noise, friend from threat. The earliest biological computers were soft, decentralized, and floating in the deep ocean. The first major upgrade, the development of a basic nerve net, is demonstrated by creatures like the jellyfish. This decentralized system allows for instantaneous reaction across the entire body, sacrificing deep analysis for speed. Speed is survival, but true cognitive complexity required centralization. The second great leap, centralization, exploded during the Cambrian period. Hunting became complex, necessitating speed and direction. Bilateral symmetry meant defining a front. Suddenly, senses were clustered, feeding into a protobrain, an editorial hub designed to manage complex inputs and coordinate direction. This was the birth of the CPU. Crucially, intelligence is defined as much by what it ignores as what it processes. The evolution of the protobrain prioritized the sensory firewall. The brain is an editor, filtering out 99% of ambient data to focus only on survival-critical information. Energy costs drove this ruthless efficiency. Cognition is metabolically expensive. As life moved onto land, the predictive problem escalated. 3D environments require sophisticated spatial mapping and superior memory, the third great leap. The emergence of the mammalian hippocampus provided this crucial tool, allowing creatures to build mental maps, remember food caches, and optimize navigation pathways far in advance. But the ecological pressure that truly accelerates intelligence is the presence of other intelligent minds. The fourth leap is the social calculus. Predicting the actions of rivals, forming alliances, detecting deception, this is the ultimate computational challenge. In primates, intelligence became a weapon for navigating complex social hierarchies. Group living offset the metabolic cost of a large brain. Cooperation is the ultimate survival hack. Intelligence, therefore, evolved as a team sport. The increasing density and complexity of hominin societies demanded greater memory capacity, not just for tools, but for names, promises, and debts. Tool use is ancient, but hominins introduced the critical element of abstraction. Chimpanzees use a stick. Early Homo habilis conceptualized a hammer and planned its creation for a theoretical future need. This shift from reactionary tool use to planning for the unseen future is the thin line between basic computation and abstract strategy. Then came the final and most defining leap: language and symbolic thought, roughly 70,000 years ago. This wasn't merely a complex way to convey danger or food. It was the capacity to bind arbitrary sounds to abstract, unseen concepts. Language is the hardware upgrade that allows for the structuring and sharing of reality itself. This ability created the shared reality, enabling collective mythologies, shared fictions, gods, money, nations. This cognitive leap scaled cooperation from small familial bands to millions of unrelated individuals. No other species possesses this ability to coordinate based on mutual belief in things that do not physically exist. But this self-awareness came at a profound cost. We developed acute predictive abilities, allowing us to foresee our own mortality and the consequences of our actions. Anxiety, self-doubt, and existential dread are the necessary byproducts of superior prediction and abstract thought. The human brain is fundamentally wired for recursive thought, thinking about thinking. This recursion drives the scientific method, philosophical inquiry, and technology. We are not just processors. We are self-diagnosing, self-improving analytical engines constantly seeking patterns in randomness. The modern paradox is this: we are navigating a 21st century global network with an operating system optimized for the Pleistocene savanna. Our ancient wiring struggles to process abstract digital risks, global political threats, and the infinite unfiltered data streams of modern life. This brings us to the future. If evolution constantly favors efficiency and optimization, the next step may require non-biological substrates. AI does not face the constraints of a 1,400-gram brain requiring 20% of the body's energy. It is ready for the sixth non-biological leap in computation. This raises the most critical philosophical question of our age. Will the next intelligence be conscious or merely hyper-efficient at pure optimization? To the indifferent universe, perhaps only the result, the efficiency, matters. But for humanity, the distinction between awareness and algorithm defines our future relevance. Intelligence is the universe's mechanism for observing and understanding itself. Its value transcends mere survival. It is the engine of comprehension. We are witnessing the beginnings of a second Cambrian explosion, this time cognitive, where the substrates of thought are becoming infinitely malleable. Understanding the deep architectural history of our own minds is not just academic. It is crucial now, as we design the parameters and the values of our successors. Every constraint we overcame, from the basic nerve net to symbolic language, built the framework for what comes next. The question is no longer how intelligence evolves, but what kind of predictive capacity humanity values most: efficiency without feeling, or the self-aware, messy struggle of consciousness. Analyze the architecture of your own thought. If this investigation resonated with your curiosity, like this video and subscribe for more deep analytical dives. What do you think will be the sixth great cognitive leap?